5 minutes. That is faster than a gas pump, faster than a coffee order. Faster than anything the American EV industry has ever come close to building. BYD just put a battery into production that charges in 5 minutes, survives over 1 million miles, and will still be working long after the car around it has fallen apart. Detroit does not have an answer. Tesla does not have an answer. And here is exactly what BYD built and why it changes everything. To understand why this announcement hit so hard, you need to go back 30 years. Not to a gleaming research lab, not to a Silicon Valley campus with ping-pong tables and free kombucha. You need to go back to a small, cramped workshop in Shenzhen, 1995. A 29-year-old chemistry researcher named Wang Quanfu had just walked away from a stable government job in Beijing. He had borrowed 2.5 million yuan from his cousin, and he had one conviction that most people around him thought was borderline delusional, that China could build better batteries than anyone else on the planet. He started with mobile phone batteries. Within 5 years, BYD was supplying Motorola, Nokia, and Samsung. By 2002, they were the second largest mobile phone battery manufacturer in the world, not in China. In the world then, in 2003, Wang did something that made the entire global auto industry laugh out loud. He bought a small, failing Chinese automaker and announced BYD was going to build cars. Cars powered by their own batteries. Wall Street was not impressed. Analysts called it a distraction, a vanity project. A mistake. Then in 2008, Warren Buffett's Berkshire Hathaway quietly bought a 10% stake for around $230 million. Buffett, a man who has publicly said he does not invest in car companies, ever bet on BYD, the smart money on the planet, started paying very close attention. Fast forward to 2024. BYD sold over 4 million electric and plug-in vehicles, more than Tesla, more than Volkswagen, more than any company in the world, and the obsession with battery chemistry that started in that Shenzhen garage. That obsession is exactly what BYD just weaponized on March 17, 2025. Before we get to the announcement, we need to talk honestly about why electric vehicles have not taken over yet. Because the answer is not politics. It is not oil lobbying. It is not that Americans love the sound of a V8. It is something much simpler. The technology still has real, painful, everyday problems. Problem 1. Charging time. Pull into a Tesla supercharger today, the gold standard of fast charging in America, and you are looking at 20 to 30 minutes for a meaningful charge. That is not a pit stop. That is a meal break. Compare that to 4 minutes at a gas pump, and you immediately understand why millions of drivers still hesitate. Problem 2. Range anxiety. The average new EV in 2024 delivers somewhere between 270 and 320 miles of range. That sounds reasonable, until you are in rural Nevada at 9 in the evening. Battery sitting at 40 miles, and the nearest charging station is showing a red error light on the app. That moment, that specific stomach-dropping moment has killed more EV purchase decisions than any advertisement ever could. Problem 3. Battery degradation. Every charge cycle, every aggressive fast charge session, every winter morning spent in freezing temperatures, the battery loses a fraction of its capacity, quietly and visibly, until one day that 300-mile range has quietly become 220. After 10 years, you could be facing a battery replacement bill that runs anywhere from $10,000 to $15,000. For a lot of buyers, that is not a future they want to sign up for. Problem 4. The supply chain nobody wants to discuss. Around 70% of the world's cobalt supply comes from the Democratic Republic of Congo, where the human cost of mining is genuinely disturbing. Lithium extraction in Chile is draining aquifers in one of the driest landscapes on Earth. The clean car, as it turns out, has a very complicated and often very dirty origin story. Problem 5. The grid. America's electrical infrastructure was designed decades before anyone imagined 250 million electric vehicles all plugging in overnight. The Department of Energy has been raising quiet alarms about grid capacity for years. The warning is not hypothetical anymore. It is an engineering reality. So the question that has been sitting unanswered at the center of the EV industry for a decade, is this What if all 5 of those problems could be solved at once? Not in theory, not in a lab, in production, on the road. Right now, BYD's answer to that question is what makes March 17, 2025 a date worth remembering. Wang Chuanfu walked onto a stage in Shenzhen and unveiled what BYD is calling the Super E platform. And the numbers he presented did not just raise eyebrows. They stopped the entire global electric vehicle industry cold. Let's start with charging speed, because the number is almost offensive. The Super E platform supports peak charging at 1,000 kilowatts, 1 full megawatt of power flowing into a single passenger car. To put that in perspective, that actually means something. Tesla's V3 supercharger, the fastest public charger currently operating in the United States, maxes out at 250 kilowatts. BYD's new system is 4 times faster than that. Not marginally faster, not incrementally better. 4 times the real-world result. 5 minutes of charging delivers approximately 400 kilometers, roughly 250 miles of range. That is not a controlled test environment figure padded for press releases. That is the number BYD is putting into production vehicles right now. The charging stop is no longer a break, it is a pause. Now let's talk about the battery itself, and this is where the chemistry gets genuinely interesting. BYD's Blade battery runs on lithium iron phosphate chemistry, commonly abbreviated as LFP. No cobalt, no nickel. None of the rare earth materials that make the EV supply chain ethically complicated and geopolitically fragile. The structural design is equally clever. Rather than stacking conventional cylindrical or pouch cells inside a module, BYD engineered the cells themselves into long, flat blade-shaped units that slot directly into the battery pack and actually contribute to the structural rigidity of the vehicle floor. Fewer components, less wasted space, better thermal management. The engineering is elegant in the way that the best engineering always is. It solves multiple problems with a single decision. Now the durability claim, and this is the number that has American engineers genuinely unsettled. BYD states the Blade battery is rated for over 5,000 full discharge cycles. Run the math on that against average driving distances, and the conclusion is almost uncomfortable to accept. The battery will outlast the car it is installed in. Not by a little, by a significant margin. The chassis will rust. The suspension will wear. The interior will fade. And the battery will still be sitting at well over 80% of its original capacity. And then there is the safety demonstration that went quietly viral in engineering circles. BYD took a Blade battery cell and drove a steel nail straight through it on camera. The kind of penetration test that causes conventional nickel-manganese, cobalt cells, to go into immediate thermal runaway fire, explosion, catastrophic failure within seconds. The Blade battery's surface temperature, after nail penetration, stayed below 60 degrees Celsius. No smoke, no flame, no drama. Finally, the voltage architecture, and this is the engineering detail that makes all of the above possible. The Super E platform runs on 1,500 volts. For reference, Porsche's Taycan, Hyundai's Ioniq 6, and Lucid's Air, considered the most advanced production EV platforms currently available in Western markets, operate on 800-volt architecture. BYD is running nearly double that voltage. Higher voltage means lower current for the same power output. Lower current means less heat. Less heat means you can push charging speeds that would otherwise melt cables and destroy connectors. The physics are not complicated. The execution, however, is extraordinarily difficult, and BYD has clearly done it. Here is where the story stops being about one company and starts being about a much larger shift. BYD is not a domestic Chinese brand anymore. They are the top-selling electric vehicle brand in Thailand, Brazil, and Australia. They are building manufacturing facilities in Hungary, Turkey, Mexico, Indonesia, and Brazil. The global footprint is expanding faster than most Western analysts projected even 2 years ago. Those megawatt charging stations, BYD has announced plans to deploy more than 4,000 of them across China by 2026. This is not a roadmap slide on a presentation deck. Construction is already underway. Meanwhile, in the United States, the federal NEVI program the National Electric Vehicle Infrastructure Initiative promised 500,000 public chargers by 2030. 5 years into that program, only a few hundred have actually been installed and operational. The contrast is not subtle. Because of 100 PHNTRM tariffs currently imposed on Chinese-manufactured BYD passenger vehicles, American consumers cannot buy a BYD car even if they want one, which means the technology gap is not theoretical. American drivers are being locked out of accessing a charging and battery standard that is, by objective measurement, years ahead of what the domestic market currently offers. And BYD's ambitions extend well beyond passenger cars. BYD batteries are already running electric buses in Los Angeles. They are powering grid-scale energy storage projects in Australia. They are being integrated into commercial trucks, ferries, and neighborhood-level backup power systems. Wang Chuanfu has said publicly that the goal is not to outsell Tesla. The goal is to fundamentally rewire how the entire world stores and moves energy. The car is the entry point. The grid is the destination. While the United States continues debating timelines, incentive structures, and which decade makes sense to begin phasing out combustion engines, China built the answer, scaled it, and started shipping it. This is not a story about one battery or one company. This is a story about who gets to define the next century of energy and transportation. And right now, that conversation is happening in Shenzhen, not Detroit, in Chongqing, not Silicon Valley. The future of clean energy is not a concept on a whiteboard. It is already on the road. The more important question now is not whether BYD's technology is real. The specs, the nail tests, the production numbers, those answers are in. The question worth sitting with is this: how long can the rest of the world afford to wait before catching up? If this breakdown changed how you see the EV race, share it. Subscribe for the next deep dive. And drop your take in the comments. Can America close this gap? Or has the window already closed?